Hi class, we need to take a look at example 7. Now, example 7 basically has the same type of problems that we did earlier in terms of an intersection and a union. And basically an intersection is the solution to both of the sets, whatever they have in common. A union is putting both of the sets together and technically not expressing the intersection, twice. And if we look at the first problem, all of these are two-dimensional inequalities. So you would be told that they're two-dimensional inequalities, or they're going to give you the x and the y axis because they could be confused as x's and y's. Now, for the first inequality, we're just going to graph y is equal to 4, and it has a y-intercept of 0, 4, and technically slope of 0. The second one, we're going to graph x is equal to -2 with a dotted line. And as the x-intercept, it's going to be -2, 0. And well, technically this slope is undefined, which means we have a vertical line. So let me graph those two, and then I'll do the shortcut for the testing of the points. Okay, so here's the first line. This represents y is equal to 4, 1, 2, 3, 4, with a solid line. And let me just make it a little bit thicker. And then we're going to do the vertical line at -2. And let me make it a little bit thicker and then technically dot it. Oh, it's not gonna let me, it's gonna, let me insert it again. Okay, here we go. Let me just do the line a little bit thicker and then also dot it. Now, remember that we're doing a dotted line because it says it's less than -2 and y greater than or equal to 4. So greater than or equal to 4 is going to be solid. Now, the next portion of what I'm going to do is I'm going to do the actual shortcut on the test points. So for the first line, because it says greater than or equal to 4, greater means above. So we would be shading above the line. In this case, all the values above the line would be shaded. The second one is less than -2, so technically every value to the left. And then in this case, for the intersection, we're looking at all the solutions that happen to be shared with the line. So in your intersection, it's just going to have this quadrant as shaded. That's it for this one. Let me graph the union, which is technically part B. And let me pause the video where I'm just gonna insert the lines of these two into the graph and then do the union. Okay, I'm just gonna jump to part B where we're doing the union. Now, remember that we already did the intersection, and the intersection is the set of the plane that can shade it twice. So technically for greater than or equal to 4, you shade above, and less than -2, you shade to the left. So this corner was shaded twice. On the good news, when they're asking us for the union, you're putting both of the sets together. So we're putting this set and the second set together as one. So technically what this is going to represent on the union is that for the second one, we're shading everything to the left. So technically everything to the left gets shaded here. and then greater than or equal to 4, everything above gets shaded. So union, you shade, well, everything on the plane for both of the solutions. Notice that this portion was shaded twice. This is your intersection from the first part. So that represents this portion. That's actually it for problem 1A and B. Let me show you how these look with technology. And here I have 1A and B. Notice that the software is giving us this portion here. This is the intersection of the statement, or technically the and. And then the union, it's going to be putting all of these together, which is what we did here. Both of these together. Here you can clearly see that this portion gets shaded twice. That represents technically the intersection of one solution and the second one. That's it for this problem. I'll put the other ones on a different video.